Well, hopefully it's big. Big? Good times? Is that blurry or anything?
Yeah,
Cool?
but unless you have small text.
I don't think it gets any smaller than my name down there.
Okay, that's fine.
Maybe when we start monkeying around with the thing, but. Good to go?
Yep, go for it.
All right, here we go. This is my presentation on Neo4j. It's a graph database. And at the bottom there, that's my name. I'm Tim. If you were here last month, you know I like writing PHP and doing jujitsu. So that's me. Let's get cracking. This talk is an intro. If you're like a graph database stud, you're going to find this kind of boring. If you've never done graph databases before, then this is the talk for you. This is really cool. Yeah, the reason for that is pretty clear. It's because I also barely know what I'm talking about. This talk is a cheaper version of a talk I saw at PHP Tech Chicago. So as far as like the learning curve here, I had a wonderful 1 hour intro to graph databases, and I'm going to roughly repeat that 1 hour back to you, and then hopefully at the end we're all on the same page and you can go monkey with Neo4j. But it's entry level. I can only give you what I've learned and found in the meantime. So fair warning there if I sound ridiculous. Graph theory. It's the fundamental principle behind graph databases. It's the mathematics that make all this work. It started with this mathematical problem, kind of a historic mathematical problem of the 7 bridges of Königsberg. Don't go looking for them. 2 of them no longer exist. But at some point, there was 7 of these bridges. And a man by Leonard Euler attempted to figure out if you could cross all 7 bridges without crossing them twice. Of course, he proved that was impossible. But this laid the foundations for graph theory and mathematical topology. Euler is actually a pretty studly dude. He invented or came up with a lot of the mathematical notation we have today. If you've ever seen like f parenthesis x as far as like a function call, that's Euler. The little e to the x, that's Euler. Like he's a humongous figure in mathematics, but I'm not really smart enough to understand all the math behind graph theory. As you see, the 7 bridges there kind of over time kind of get down simpler and simpler, and we end up with kind of this concept of a node map. But again, graph theory backed by very complex, very cool mathematical procedures, and if you're a guy that's into that sort of thing, I encourage you to go check it out and have fun with it. But I'm not the guy. I'm not a math whiz. There's thousands of pages of published material on graph theory that you can get into. All right, it's cool. I'm full screen. I got it. All right. Anyway, that's where all this comes from, and that's about all the math we're going to do. What does graph data look like when we put it in a graph database? Nodes. Hurrah. Soak all that in. Nodes have properties. They're schema lists. So I made a node for myself over here with a property that my hair is long, and over there I made bacon. Again, schema lists, they can have infinite numbers of properties. The properties can be anything. You can name them anything. Much like if you've worked with Mongo or any other schema list database, you just throw data at it however you please, and you can query on it later. Yippee. Nodes also have relationships. So here I have associated that I love bacon. Relationships can also have properties. This is how you would give weight to things, i.e. you could say, I really love bacon, or I kind of love bacon. This concept is stored. When you make a relationship in Neo4j, you store the relationship on write, unlike a traditional relational database, which actually calculates it on read. You know, we all make our associations and join again and join once more, and then it'll bring back the right data set. These relationships are actually persisted, which makes it incredibly fast for reads. So there's my dog about relationships. All right, who's using graphs? Why do we care about this technology? Why is Neo4j or its related projects worth our time? Everyone. Everyone who's anyone. And you one day. Facebook. That's the biggest one. I'm sure you've heard of the open graph. Your friends like what you like. I'm sure you've gone on Facebook and you accidentally clicked an ad, and then that ad will not leave you alone for a month. I'm sure you bought something on Amazon, and then related products always showing up on Facebook. The reason Facebook is so creepy is because of the graph. If you get enough nodes, they can run across those nodes and figure out what you're into. Same thing for our friends at Twitter. It's a whole recommendation engine. Who you follow, who you tweet, those emails you get if you're on Twitter about maybe you should follow this person. That's all. Those relationships are all graph theory. And then GitHub. Finding all the if you've ever gone up in the corner and clicked the fork button and you can see all the forks and where they go and all the branches, like that's a graph. If you've ever looked at your contributor page, though, that's graph data. So it's everywhere, and there's a million more of them too. Advertising, that's the big one. Dating sites are almost exclusively data graphs. Finding out via some characteristics you put in. I like 8-foot-tall women with blue hair. You know, they hunt that down. That's a data graph. Geospatial, a lot for that. Scientific research. BI, that's a big one. That's emerging. A lot of places are putting graph databases on the back end to say, okay, we have these giant data sets. We have these volumes and volumes of data, and we get so little value out of it. By getting it into a graph database, sometimes you can see, oh, our customers who bought this product also bought this product. Maybe we should package them together. We sell a lot on Tuesdays, but only in this particular section of our products. Maybe that's the day those should go on sale. Things like that are exceedingly difficult or cumbersome to calculate in MySQL. Dare I say you would probably offline them and go to like an ETL. Pretty darn easy in a graph database. And we'll monkey with some of that stuff later, and I'll show it to you. Which brings us to Neo4j, a particular implementation of a graph database. Sponsored by Neo. Well, it's a NoSQL graph database. I copied that off of their wiki. Use cases include matchmaking, network management, software analytics, scientific research, routing, organizational project management, recommendations, social networks, and more. Basically what it means is anything where you have relationships. And more, that's kind of everything. That's what really got me excited about working with graphs, is that, you know, as much as we say, we don't need the hassle of a graph for this project, we've just got a couple tables here, and we can just use the old way. It's fine. More and more, those advanced analytics that people want to run. How many customers are between 35 and 26, are female, and are in Alaska? Pretty easy query, honestly, in Neo4j. This is our representation of our old way of doing things. Relational databases, despite the name, actually kind of terrible at relationships. I, looking back, don't know where that term really came from. But relational databases calculate relationships on the fly at scale. Sometimes it can fail us. So we've got our idea of tables. You've seen this 1,000 times because you've all worked in MySQL, I'm sure. Tables have relationships. We get a join table in the middle. And there's how we query our data. Do it on the fly. A couple joins there. Same old, back to work. In most cases, we're probably using an ORM that does all this for us. We've made software to handle our software. Actual relationships look kind of like this, and they're much more direct. The arrows in this case being persisted. We have things that are pasta, we have things that are Italian food, and spaghetti is both those things. Graphs. All right, let's get into Neo4j specifically. Cypher, declarative SQL-inspired language. It's how we query a graph. It's how we query a Neo4j, and it's not bad. It's going to look a little different, but once we get into it, it's pretty SQL-like. If you have worked in MySQL, then you're going to make an easy jump to this. It's ASCII art. It actually draws with pictures. If you look at the picture up top, you have node A, relationship B. They literally, in the language, attempt to draw that little arrow right here. That's what that is. So you're really just kind of drawing these relationships, and you bring back data. So if you keep in mind that you're drawing a little picture, you'll always get the arrow in the right direction, or sometimes when you don't need it, everybody lives on. It's good times. All right. Yeah. Totally. All relationships in Neo are directional. You can query one way, and then you can also say the direction doesn't matter. You can query kind of omnidirectionally. Let's make some data. This is a little nice comparison here. This will make. Here's how I would make a new node, and I named it after me. The JSON payload over there is indiscriminate. You could put name, last name, first name, middle name, things that aren't named, phone number, doesn't matter. That's all it takes to make a node.
And the node is the JSON object?
Yep. That's just think of it like a record in a table. You just made a record here. Here's how we make a relationship. The first line of our cipher finds us that we just made. All right, go get yourself. Then create a relationship that says, I like Neo4j. Plus I gave it some extra handles there, and I'll explain those later. And then our return clause allows us to return various parts of these things. I don't need this. I already have SQL. So I thought I would show you examples of Cipher versus SQL and see that this is not that bad. Is it that different? Cipher includes many of the things you see in traditional SQL: where clauses, order, limit, and mathematical operators. None of this stuff is foreign if you've done that. Here's what SQL, here's kind of select all from a table. Select from P, from products, that's P, give me everything. And in Cipher, it says match P as product, return P. No big deal. Not a big problem. Not a wildly different syntax. Slightly different. Order of operations is a little funky, but you know, we're not way out in the weeds here. Here's a little more complicated example with a limit clause. Select P, product name from products. Order by the unit price, give me 10 back. Match on product, give me the two pieces of data I'm looking for. Order by price, limit 10. Not so bad. It's all right.
I assume if in the node when the node's created or the object's created, if you don't give it a unit price, it'll just return back null or empty or something.
It won't find that thing, yeah.
So if you give it a product name but not a unit price, will it not return still for the?
Yeah, if you ask for, in this case, there are ways to look for things. There's kind of like a fuzziness where you'd say if it's there or not. But in this case, if you ask for a property and it's not there, it goes on to the next one. So I'm not worried about ones that don't have the thing you're asking for. Here's kind of more advanced example, and this hideouts thing is just being so cool about being right in the middle of this.
User-friendly.
It's not showing up on the actual thing.
Oh, really?
No.
It's not right there?
It's just on your screen.
Well,
Hold on a second. Let's see if I can get rid of this guy. Ah, get out of there. Show who should be. Huh? We good? There's just no winning. Okay, pretty easy here. We've all made this query probably once or twice in our life. What companies bought Chocolate? A fictitious product that I got off the Neo website. Find customers, join on orders, order details, which functionally like line items, join products, and then find the chocolate. Great. We've all made that query. Not so bad. 3 joins. In Cipher, we're looking for nodes called Chocoaid with a relationship, the product to an order, to a purchase, to a customer. Find distinct by customer or company name. Right here is all that linear join. And you can see it's all these little pictures. Here we have a node that's customer. We have an arrow with the name purchased. We have an order node. We have an arrow over product. And back to our product. Righteous. Here, this next one. Oh, never mind. I got one more. Best salesman. Here's using some of our aggregate functions like counting up. Order, sold, employee. Couldn't be simpler. What do you want to find? Orders, sold, employee, count up the most. All this SQL comes down to 3 pretty easy, pretty readable lines. And then this next one is the coup de grace, which we've all done, and it's just the worst. Hierarchical nesting inside MySQL or any SQL base, where you're just looping over like a parent ID over and over, and you're going 5 levels deep. Awful. Node gives us this, or Neo4j gives us this nice little parent operator that just says, run it up the chain. It'll traverse up the tree as far as it needs to go. You can also use this to control it. So you can say, go 2 levels up the tree, go 3 levels up the tree, go 50 levels up the tree, go all the way to the top. But you can see this wild, sprawling mess of a query, which is probably even larger than that box, gets down to some nice, semi-reasonable picture. So go get dairy products. Anytime I find myself looping over MySQL nowadays, adding joins, join to parent, join to parent, join to parent, join to parent. Great place for a graph.
Yeah. Like how many times did it say 5?
How many levels deep do I go? Plus, you know, there's a lot of knowledge you have to have on the front when you're doing something like that. How many levels do you want to go? I want to go 5 deep. All right, 5 joins. Bah, 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 bah. I want to go 6 deep. Bah, 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 bah. With Cypher, just go as many as there is. Query never changes. There it is. Using this in PHP, Neo4j is backed by a pretty easy REST API, and there is a project to talk to it. So most of the work is.
Neo4PHP.
It's called Neo4j PHP, yeah.
What was I saying? It should be called Neo4PHP instead of Neo4.
I mean, the product's Neo4j, but Neo4PHP, pretty sweet name. Anywho, it's not what he named it. This is what it is. A pretty normal API, you know, let you get in there, make a thing, add some properties, save. That's it. There is some work being done on like ORMs and stuff like that for graph databases, but it's like way beta. So at the time, this is pretty much what we got, but it allows us to do, you know, the basics of creating CRUD operations, deleting, other things like that. And then I was going to show you that. I'll show you that REST API, and we'll mess around with Node. Sorry, Neo4j. I don't know why I keep saying Node. It's because you said Node earlier. Gordon screwed me up. All right.
We had Node in the very beginning thing.
When you open it up, if you see this is running on localhost, this is what it looks like. This is about the most beautiful version of a CLI I've ever been given by a database provider. I love this thing. But it allows us to do some pretty fun little stuff. I put some metal bands in here because that's what I do. So if I click on Friends With, it'll automatically run a little query here at the top. And I get this little thing I can tug on. And it says Tim is friends with Bill, who's friends with Jeff, who's friends with Ted, who's also friends with another Bill. And you can open any of these up. You can look at them in the rows. I don't have a return statement on that, so it's not real helpful. But that's kind of what we got here. I got a listens to here, nice little graph. Said Ted likes Metallica and Slayer and Anthrax. Tim listens to Faith No More and Pantera. You know, I don't know why dragging these nodes around is so fun, but I assure you that it is. It lists your relationship type there on the little lines. And you can, you know, bang around on this to your heart's content. This is for all intents and purposes the terminal to interact with this database. You could run some kind of advanced queries. I ran one down here. If I pull this guy up and run it again. All right. Oh, it goes to the top there. Duh. I'm just missing it. All right. We've got a match clause here. Find me. last name Cleaver. That's me. Find an artist that I listen to, and find a person that also listens to that, where I'm not friends with this person. So find someone out there who listens to the same music I do. Return person count, artist. When I run that, I find that my new best friend should be this guy, Bill. Bill Preston Esquire. But that's really, I mean, to think I can traverse from myself to an artist I listen to back to people that I'm not friends with in 4 lines? That's a pretty advanced query in MySQL. There's other ones here. I had a recommendation engine for myself. So find an artist that belongs to a genre find an artist that belongs to a genre that I listen to, but that is not currently on my listens to list. And it brings me back that these things are probably bands I might like. Anyway, that what's up? That's the kind of the bulk of my Neo4j-ness. I encourage you to install it. If you are running a newer Ubuntu, it's on apt-get, so it just installs, and then you pull this up, and you can start making objects and stuff like that. It's pretty cool. I've got a small subgenre graph in here that says got different kinds of metal, and you can query up and down the tree based on things you like and don't like. But this is what Neo4j looks like. That's the bulk of my presentation. That's kind of it as a storage engine. If you got questions, I'll be glad to do my best. But I got real excited about this because it's really, it can scale up with clusters to billions and billions of nodes, and you can query just outlandish things pretty simply. Just in monkeying around with this, making a recommendation engine in 1 line, that would have taken me, I don't know how long in MySQL. So hit me the old question. What's up?
Can you see the data table somewhere?
This is the data. These nodes right here, that's it.
Well, yeah, but you're filtering them. Can you see like a list of?
Yeah, I mean, you could definitely like pull up, let's say, artist here, and then I can go to the top, and there's all my artists, and you can see them by rows if you wanted. The only problem with seeing it as a table is that they might indiscriminately not contain all the same data. Who knows what's where? Different properties. I mean, they're roughly related because I said they're related. I told it these things are artists, but what that means in the context of my application can be kind of.
There's no grid because it could be all different.
Could be anything.
Is there any limit to the size of the JSON object you can store as a node?
Nope. I mean, I'm sure there's some physical limit at some point, but there's no limit on like parameters or things like that. Yeah, I mean, I assume they can get
one node Wikipedia.
all of Wikipedia, all linked up. Yeah, I mean, there's obviously tiny example, not a whole lot of data here, not a ton of limit there, but it's scale. They said billions of nodes, so I have to assume this thing gets pretty hot.
Are there CLI tools?
This is the tool. This is the tool.
Just all through the API.
Yeah, this actually just sits on top of the REST API. You can bail on this and just go with the REST API natively. But this thing is pretty keen. And yeah, there's no CLI tool because kind of a tough syntax to visualize with.
I was just wondering if there's, an easy way like export and import data.
You can certainly do it.
You just have to build your own.
Yeah, you just bang through the API and bang it down to a file.
So it doesn't start its own program where you say you have to interface with it with the API, right?
It has its own internal API that it exposes. That's how you talk to it. Like you don't talk to it at the socket level like maybe you would with MySQL. Although I think there are ways to do that. But out of the gate, it just gives you an API, lets you start making nodes to your heart's content. And that's what this actually sits on top of. But yeah, whatever application you want to start shoving. Again, there's no schema, so they can't really you don't have to set anything up. You just start hitting it with data.
Is there security built into it? Users and stuff, or?
There can be, yeah. There's some level. I didn't mess around with security too much. This is kind of out of the box install. I'm almost sure there's something, but maybe not. Some of these things, especially, they might just be like hide it behind a wall or something like that.
For the connection. Just gotta be a connection.
You probably wouldn't want to expose your database directly.
Right, especially since it's REST. So if you knew the structure, you could just start hammering data into it.
Post all the things.
Yeah, post Gordon to top salary
This is
earners.
what happened with that dating website. Oh yeah, that cheating website. Is it?
Yeah, Ashley Madison.
I heard some
Yeah.
Yeah.
There you go.
This is I have to
That is
assume,
an internal job.
Yeah.
not knowing their data structure. I mean, they have to be backed with a graph somehow if they're going to start matching people.
So is this similar to Cassandra, or is it Cassandra? Is that-
Cassandra's columnar, so that is
I thought
different.
that was where you can just get your own JSON data as well.
Yeah, that's not similar at
So,
all. Cassandra's like.
well, there's no relationships like this, right? It's different.
Yeah.
But still, the data is not. It's not.
Wherever the way it stores it is completely different. They're not even close to each
Cassandra actually is a database, right? Is this flat file or how's it stored?
I believe it's flat file somewhere.
XML.
I believe it. I believe under the hood it's flat file. It's making a point to persist those relationships on the way in.
It writes everything to big PNG.
I mean, yeah, I don't know what it uses, but like Cassandra, I believe is doing stuff in ordered tables.
Yeah, they've got a concept of super column and which
Yeah.
kind of roughly maps the table and things like that.
Well, I mean, it's a column or a table store kind of on the big table, SS table model, which conceptually is very different from a.
Oh, you know what you can put binary objects in there?
Stuff anything in there you want. Anything you can put into JSON.
Well, it's text, right?
Base 64.
I mean, it's written in Java. I would not want to put huge nodes into it and then try to scale it. It'd be kind of like the power of something like this is the relationships, not like
You wouldn't
the schema.
you wouldn't shove images into it.
Right.
That'd be dumb.
Probably not. And I've also seen we talked about, to your point about that, we've talked about installations where the relationships and the mapping is persisted in Neo4j. The actual data is still in MySQL. So you end up just getting IDs back very quickly, and then you just say, okay, go get those IDs, or keeping all that in Mongo.
Right, yeah, I mean, but yeah, I mean, like the use case of something like Cassandra where it'd be like, oh, I want to store 10 terabytes of data is not at all overlapping with the use
I was
case.
just thinking potentially just like if I have users, just be like
Yeah.
users.
Could.
Binary data in any data store that's not something along the lines of Cassandra or HBase, or it would be a bad idea. It's even a bad idea on MySQL or Mongo.
It's a could versus should problem. Can you do it? Absolutely. Do you want to do it? Maybe not.
I mean, you would probably really hurt yourself on the 4JA pumping huge elements through it because you're gonna cause large GC posits, and yeah, it'll say bye-bye once you start doing that.
I'm sure it probably tries to store as much, if not all of it, in memory.
Right.
Yeah, it does its best to keep everything in memory.
And it's really inefficient to have these huge properties hanging along that you don't really care about most of the time compared to relationships, which you really do care about. I mean, it's the same with MySQL design, right? Like if you put one table that has 800 columns and including 700 blobs, the performance is going to be really bad.
Yeah,
And indexes on all of the columns.
definitely. Always index your blobs. That's the secret. That's the secret to becoming Facebook.
So I'm sure you can make Neo4j run horribly by abusing it. You can do that with any data store.
Yeah. to that point, I've heard of it used just as a relationship manager, and then having Mongo sit next to it or something like that. I don't assume that's even a problem you need to worry about until you have like a really high scale app. I haven't performance tested this thing. You know, all I can do is repeat what Neo4j tells you, which is probably a little optimistic, but they say billions of nodes. So the whatever.
Well, I mean, the documentation doesn't say billions of nodes on a single server, so.
Yeah, it certainly doesn't say single service. It's clustered billion. So it's where the truth lies, probably somewhere in the middle there. But
I mean, you don't abuse it, I'm sure it scales fine. And if you abuse it, I'm sure it doesn't.
any other?
That same way.
Any idea on how they do the graph so dynamically?
You mean the actual how they draw the pictures?
Yeah,
Is that a flash? Is that a flash?
I doubt it's Flash. I bet it's Canvas. I don't know. I can look.
Could be SVG.
It is SVG right there. Yeah, drawing little circles.
Yeah, it's way easier to do something like that in SVG where you have a circle primitive than in Canvas where you have to
Build your own circle.
draw the circle.
Actually reinventing the wheel. Circle.
But yeah, all these relationships end up being queryable. You can through your queries, however you want to do it, you can traverse anywhere through here. Aggregate, collect.
So have you done anything that's kind of, like the data you put in there is pretty like classical graph data?
Sure.
On the relationship to entities?
Yeah.
Have you used it for, like, all right, like instead of building a standard, line of business CRUD app, instead use Neo4j as the backend?
I haven't. Neo4j is pretty new to me. Just started monkeying with it, so I don't even have it in production anywhere, let alone like outside use cases. But having,
I don't see why it wouldn't work. I'm just wondering.
yeah, I've never done it. I don't know what things you'd run into. Having done the same with Mongo though, I can't assume why it wouldn't just.
No, I mean, I don't
Just
see any
fine.
problems. It would be different because of how you model relationships.
Yeah. The other thing I would wonder about, just as far as everybody's always worried about time to market and RAD and getting thing out the door. Not a ton of tooling around this. Some, enough to get you by, but there's not like, oh yeah, just install this project and you're ready to go. Not as much of that as you would hope. But there's no doctrine for Neo4j, I guess is what I'm saying.
I don't think it's necessarily a bad thing.
Depending on your opinion of that project. But yeah, that's all I've done is kind of monkey with the REST API and bang out some queries that traditionally would. Doesn't shock me. The list of people that are using it's pretty lengthy.
I mean, anytime you're doing recommendation stuff where you're relating people and the items they buy or the things they view and the things they like, it seems really easy to model in Neo4j. It's like way easier than to query those complex.
Yeah, as soon as you find yourself making like two logical hops, it kind of becomes at least a conversation you could talk about going to a graph. Like people who know people who buy things that are like other things. Like that'd be a classic reason to go to a graph.
Yeah, I mean, a lot of that's, once you go deep like that, you can't really do it inside a SQL in a single query. You end up using a processing step. So it's nice to have something where you can query it directly.
AOL is using it. I'm sold.
I'm sure they're using it for.
Hey, we own
To try and stop
AOL.
the bleeding.
No. Well, I mean,
That's right.
it actually worked, right? They got bought by Verizon because of their algorithmic advertising product. And I'm sure algorithmic advertising uses graph theory to find the ads that match you best. So it somehow worked. It stopped the bleeding.
Yeah, advertising, huge for this.
Yeah.
What about just for inventory? I mean, like for Verizon, we have 100,000 cell sites or whatever it is. Would that be, and we have maybe 50 to 1,000 metrics per cell site to keep track of. This doesn't seem like it would be a.
I think you'd have to do the hybrid approach that they were talking about earlier, where you just put your IDs into this and have relationships, and then it'll turn back listed IDs, and then you just go to your SQL.
Yeah, it really would really depend on what data you want to kind of excavate out of it.
Yeah, it seems like it should be a good way to model the relationships between the nodes of your network and being able to then easily.
Like just replace your join tables with this?
Yeah, but I mean, the reality is that most people don't want to build one of those. They want to use an off-the-shelf one.
Yeah.
I mean, I looked at their website and they talk about, managing IT style data. You can see how attributes could be versions of packages, and then you could have relationships between them, showing your network hops and stuff, and that's all great, but I don't want to build any of those tools.
I want someone to have built them, yeah.
Yeah, I mean, you might be different if you have to maintain that tool at Verizon, but most people don't want to build those tools.
Yeah.
Can you visually, with this tool, build a database? Like say, draw a node and then draw a line, build another node?
Totally.
Yeah.
Totally. Backward. You want to say his date?
08/25.
Added one label, created one node, set one property for 764 milliseconds.
So can you go down there now and click on the chart and say add one and then type in stuff down on
You can build your own interface to do that.
You could. Let me see if I can just start editing randomly.
Where's your PDA have it?
Draw lines.
It looks like you're probably gonna have to issue an update command. Maybe not.
What's the data mutation model in this? Can you update individual fields, or do you have to update?
Yeah. You can. You match on a node, and then you can update its payload
Do you
accordingly.
have to send everything back to it if you just change one thing, or can you actually just update one of the attributes or elements?
You can just update one. You don't have to send anything back.
Oh,
Update can be. Update doesn't have to have a return, so you can update and then return
So
nothing.
you cool.
And you can obviously update just like your where clause in MySQL, your match criteria. You can update 200 nodes at a time if you need to. Yeah.
So what if you create a node with a, I don't know if attribute's the right word or not, but a field or whatever you want to call it of, say, date, and only half of your nodes actually have a field of date, and you do an update, would only update the ones that actually already, update date, update set date equals today, or the value today, whatever. Will only update the ones that actually have the value and date.
You could do it either way.
So you say
Yeah, it's part of your matches.
Yeah.
As part of your match, you could say property exists is date. Right, it's all contained in that match, really, and that match is the key to the whole thing. Match. Okay, it's going to bring back this subset of nodes from obviously a monstrous list. All right, here you got these. Now, how are we going to iterate and calculate and update on top of these? Yeah, I mean, there is a where clause that takes that subset and then can subset them even further. So you could say like find people with name where name Jeff. That would be a where clause. But you still have to match on.
I was just thinking that the matches is like they take the where possible.
In a lot of cases, it is. Match becomes kind of like what you're looking for, and then where becomes your.
The relationship.
Right. You'd say, or you're looking for what types of nodes. I'm looking for, because everything's a node, conceivably. Your first match might be just like, okay, bring me back users. Let's get that far. With the username, whatever. Now you got a where clause.
So would this be a good, I mean, would you use this for an e-commerce website or maybe not at that point? So I mean, there are a lot of relationships, but I mean, it's not too crazy.
I would definitely use this for an e-commerce website if you need really high-level analytics. I might use it on like the back end. Maybe not for the driving the website itself, but taking that data and turning it into something useful that maybe your internal sales office use.
And also if you're gonna be like, hey, we recommend this item.
We recommend, yeah, you might put it behind a recommendation engine. If you've got, depending on what you're selling or how you're selling it, you might say, oh, such and such buys these things, and let's get him on the horn and tell him about these other things because we know he's going to need them.
Because other people bought that thing and this other
Exactly. These products usually sell together. Or like,
Amazon probably uses the same thing.
yeah, that's sort of the recommendation. Hey, people, we've all done it. These products are usually bought together. Well,
I mean,
Yeah, that's nice.
recommendations too, but, yeah, I mean, the big problem would be for something like e-commerce would be the lack of tooling would start biting you.
yeah, your rad gets hurt. So that's why I'd say if you had a platform, if you had a voluminous amount of data, hey, we're gonna have a really successful website. We got it up, we're out the door, everything's great. But we don't even know what any of this data means. Maybe you start eating it with something like this and start running through all that data. Figuring out who's buying what part of the country, where should we send our sales guys, what time of day do certain things get purchased for? All that stuff is possible.
Have you looked into like what would like if you had like a standard database and then you had Neo4j run together and like just kind of keeping the data aligned, like if you did an update here, what it would take to replicate the data into Neo4j so that you can do like queries in Neo4j and just go.
Lots of different ways you can do that. That would kind of depend on your implementation. You can either, if you were needing something that was as slow as like batch jobs, you could talk about nightly ETLs or something like that. Or you're really probably talking about putting a data access layer in front of it and writing to both of them simultaneously.
I mean, probably the same way would be to have an event-based logging system in your application where, as updates happen, they get logged to the stream of multiple consumers, and then one could be Neo4j, another could be your search engine, and the other could be your offsite backups.
Yeah, your Glacier or something like that, yeah.
I mean, in general, once you start wanting to scale out to different backends, that's pretty much the only way you can do it and not hate yourself after a while.
Totally.
But it's cool too, because once you build that framework, you can log way more data than you ever would before. Like a purchase happened, you're not going to normally shove all those HTTP headers into MySQL or even in Neo4j necessarily. For sure, you could put them as a JSON blob that then get gzipped and stored in S3 in case you might want to put them into.
One day come along with Kinesis and do something with that data, yeah.
Right. But then, you can have a consumer that looks at the logs and just puts the stuff you need for doing recommendations in the Neo4j. So it's a very different way of looking at data, but it makes a lot of sense once you start wanting to do anything exotic. A lot of people do that with, like Elasticsearch. And then they just, for the last week, shove all that data into Elasticsearch, and then you can just run queries against it. So if you got this fraud problem, then you could run a bunch of queries against Elasticsearch, for example, and find relationships. Or you can put them all in the Neo4j and find those same relationships, where we don't, you don't want to pay to store the last year's worth of extreme in-depth data of all your orders, but for the last couple of weeks, that might be a lifesaver when you get to now stop your credit card fraud that is costing you, $1,000 a day or whatever. That would actually be pretty interesting to see in Neo4j if people are doing kind of some log analysis type stuff with it.
Yeah, I mean, obviously, in the use cases, they talk about like statistical log analysis. There's probably a product out there. I don't know what it is, but
Yeah, and it's definitely not something I want to do without a framework for it.
Yeah, exactly. I mean, obviously, if you build that framework, you better be able to sell it. But anyway, that's Neo4j. The kind of the entry. I encourage you to spin it up. Doesn't take much to spin it up. I got it running on a Vagrant here local and monkey with it. Make some nodes, connect them, query some stuff, maybe solve a problem at your work. See if there's a new way to solve it. I mean, we all have that stupid query that sits on some legacy system that's like, oh god damn it. But, anyway, that's the intro. Hope you liked it.
Thank you.